All right, welcome back. This is kind of an addendum to one of my other videos. Why? Because as I was solving a problem, I was not paying close attention to my units. I have notes in front of me. I wasn't paying close attention to my units, and I got all confused right in the middle of the video. I was very tempted to shut it down, start over, and be like, oh, I want to make this really nice video that just shows exactly how to do it. But I thought to myself, well, you know what? My students are going to be making these same mistakes. They're not going to be paying attention to units. They're going to be trying to do stuff in a hurry, especially on quizzes and tests. And it's good for them to see that somebody who's, does this for a living can still make those same kind of errors. However, that video could be very confusing if you're new to this and you're like, my professor's making mistakes. I don't like it when my professor makes mistakes. So this little addendum video shows a way of doing it, hopefully, without the unit problems. The problem we had is we had 50 milliliters of acetic acid, HAC, which we're going to abbreviate it, at 0.1 molar, titrated with 50 milliliters of sodium hydroxide at 0.1 molar. We decided, hey, we're at the equivalence point since we have 5 millimoles of each one of those. And what we're going to do, right? We made our kind of BRI table for our reaction of our HAC plus our sodium hydroxide, which we can just do the OH minus, goes to AC minus plus H2O. And we did our BRI, and we said, hey, let's normally do this in millimoles because it's just a little bit easier when volume's changing to use millimoles. We don't care about water. We said, hey, all of that's going to react. And this is where things broke down, is hold on, how funny. Okay, this is where things broke down because, timers started going off in the middle of my video where I was trying to fix other things happening. But, so I wasn't paying attention to my units, and I knew it was millimoles, and I was trying to show, hey, what happens when you don't pay attention to units, and then I even got confused because I wasn't really paying attention. So what I say is, hey, let's get down to this I. We know it's going to look something like that because we reacted all of our acid with base, and we just have that conjugate base left. But then sometimes what I'll do is I will just make a second row of I. Bryce, okay, so if it's really cold. Then obviously this is still 0, but this is where I might change my units from millimoles into molarity. Why? Because ice tables actually work better in molarity if you're going to be doing them. So 5.00 millimoles divided by my 100.0 milliliters total volume gives me a concentration of 0.0500 molar. And so I'm going to change this here now, and my ice table is now going to be in units of molarity. Now, this ice table looks a little weird because we're starting with zeros and we're not moving x over to the left. We're moving x over to the right. We are going to move x over to the left, but that's fine. So we know we're going to be going this direction, and then we get something that looks like this. Now, the only thing that was a little bit hard in this one is if you're just starting out, this doesn't look like any of our standard Kas or Kbs, but the reverse reaction does. AC minus plus H2O goes to HAC plus OH minus. Looks like a Kb, and we talked in the last video that you can't actually look up a Kb for acetic acid. You can only look up a Ka, but you can calculate the Kb by using Ka times Kb equals Kw, and you get 5.6 times 10 to the minus 10th. So we're going to go ahead and plug these things in. Just because we write it one way doesn't mean that we can't plug it in into a different equation as long as all the species are the same. So we get our Kb is going to be HAC OH minus over AC minus, and that's going to be x squared over 0.050 minus x, and that's equal to my Kb, 5.6 times 10 to the minus 10th. Okay. Small x. Great, right? We've got several orders of magnitude, many, many orders of magnitude. Small x, we got x squared over 0.050 is equal to 5.6 times 10 to the minus 10th. My x is then going to be 5.29 times 10 to the minus 6ths. That is my concentration of OH minus, and so I can find my POH, which is 5.28, and I can find my pH, 14 minus that. pH is 8.72. 2 digits after the decimal because my k's had 2 digits after the decimals. You'll notice I sometimes kept a few more digits here and there when I needed to, just and rounded at the end. So that's how we get that without making all of our unit errors. So thanks for listening, and hope I didn't confuse you too much, but I hoped it was also a good lesson in paying attention to your units. Bye.